Welcome back, everyone. In this section, we're going to talk about rates of change. So most of you can answer the question, how fast are you going whenever you're driving your car? And the answer to that question is your speed, which is just a measure of your rate of change. It's a measure of your change in distance over time. You would answer that question in miles per hour. A friend in another country would answer it in kilometers per hour. Both are rates of change. Understanding how quantities change over time, or with respect to some other variable, is important in predicting and understanding trends that occur in data. And it's one of the fundamental concepts behind mathematics like calculus. A rate is just a ratio that compares two particular quantities. When we talk about a rate of change, we're talking about a rate that compares the change in one quantity to the change in another quantity. So your speed is the change in distance over the change in time. In the movie Back to the Future, Marty McFly must get the DeLorean up to 88 miles per hour to go back in time. A speed like 88 miles per hour qualifies because we can write it as 88 miles divided by 1 hour. This compares the change in distance, 88 miles, to the change in time of 1 hour. And this is a particular type of rate called a unit rate because it has a denominator of 1. So according to the U.S. Census Bureau, about 2.7% of registered nurses in 1970 were men, compared to 9.6% in 2011. We then have the average salaries. We're not going to use that for this example. How much did the percentage of male nurses increase from 1970 to 2011? Well, to figure that out, we had 9.6 in 2011. We're just going to subtract 2.7, the change in that amount of time, 6.9%. How many years passed in that time? Well, 2011 minus 1970, that's going to be 41 years. If we want to know the rate of change of male nurses from 1970 to 2011, we can just take the percent change divided by the amount of time that passed. So 6.9% over 41 years. And then if we divide and make that a unit rate, we find that the change in percentage per year, about 0.1683%. What you saw there at the end was an example of an equivalent rate by writing it as a unit rate. We can write equivalent rates in many different ways. If you make $100 a day at a job and you work 5 days, then you could write your salary rate as $100 per 1 day or $500 over 5 days. This demonstrates a very useful fact about what we can do with rates. Particularly, we can scale them up or scale them down, depending on what situation or what question we want to answer. And we do that by just finding the equivalent fraction, by multiplying or dividing each number, numerator and denominator, by the same value. It's the same way that we simplify fractions, or we find equivalent fractions. So if we want to write an equivalent rate for 60 miles per 4 hours with 2 in the denominator, then we want to divide both of these values by 2. So if we go 60 miles in 4 hours, if we divide 60 by 2, we're going to go 30 miles in 2 hours. If we want to rewrite this as a rate with 1 in the denominator, well, now we're just going to divide both by 4. 60 divided by 4 is 15 miles. 4 divided by 4 is 1 hour. If we want to write the same rate, but we have 8 in the denominator, well, 60 miles in 4 hours. If we multiply the top and bottom by 2, that will tell us we can go 120 miles in 8 hours. So we can convert all of these values by just multiplying or dividing by the same number, top and bottom. Here, if we want to write an equivalent rate for $320 over 4 days that has a 10 in the denominator, we can take an extra step by converting this to a unit rate, $320 in 4 days. If we divide them both by 4, That's $80 in 1 day. And so now to have 10 in the denominator, if we multiply by 10, that means we're going to make $800 in 10 days. All of these are equivalent rates. If we have multiple rates that we want to compare, we can do this by converting them to unit rates or by getting them over a common denominator. So, 40 miles in 3 hours. If we convert that to a unit rate, 40 divided by 3, that's 13.33 miles in 1 hour. Likewise, we can do the same thing with 50 miles in 4 hours. 50 divided by 4, 12.5 miles in 1 hour. And so from the unit rates, we can tell that the first one is faster. Similarly, 40 miles in 3 hours, if we multiply times 4, that will give us a common denominator. We can go 160 miles in 12 hours. 50 miles, that's 4 hours. To get the common denominator here, we want to multiply by 3. And that'll give us 150 miles in 12 hours. And so we can again see that the first one is still faster, and it's just another way of comparing the rates. So again, if the median salary for one healthcare profession increased by $11,249 over 15 years, and a related field went up by $25,111 over 35 years, which increased at a greater average rate? Well, we just want to compare the two rates, $11,249 over 15 years. If we convert that to a unit rate, that's $749.93 every 1 year. We can do the same thing with the second example, divided by 35 years. 25,111 divided by 35 is 717.46 every 1 year. So which had the greatest average rate? Well, the first one did. We can also use rates to make predictions. So a particular jogger jogs 1 lap around a 400-meter track in 2 minutes. We're going to use this information to just complete this table. Every 2 minutes, he's going to go another 400 meters. So this would be 800. In 6 minutes would be 1,200. 8 minutes, 1,600. In 10 minutes, 2,000 meters. And in 12 minutes, 2,400 meters. We just add 400 each time. What's the jogger's rate of change written as a unit rate? Well, his rate of change is 400 meters every 2 minutes. As a unit rate, that's going to be 200 meters every 1 minute. Well, if we know he can travel 200 meters in 1 minute, how far will the jogger travel in 40 minutes? 200 meters in 1 minute times 40 minutes tells us that the jogger will travel 8,000 meters. But not only can we answer questions about the jogger in minutes, we can also answer questions about the jogger in other units. Sometimes it's helpful to change the units of our rate to determine answers to particular questions. So we know that the jogger can travel 200 meters in 1 minute. Well, how far can he travel in 40 seconds? To find that out, we can find out how far the jogger can travel in 1 second by converting this unit rate using unit conversions like we did a few weeks ago. For every 1 minute, there are 60 seconds. And so that would give us 200 meters for every 60 seconds. And if we divide those two values, 200 divided by 60, 3.33 meters in every 1 second. And now that we have this unit rate to find how far he can travel in 40 seconds, we just multiply like we did with the previous example. 3.33 times 40, 133.2 meters in 40 seconds. So again, when dealing with rates, sometimes it's necessary to convert the units in both the numerator and the denominator. This is just a way to make values easier to use or rates easier to understand. And so we do this very often, and it is the same process as unit conversions. So the Earth moves around the Sun at 98,000 feet per second. How fast is that in miles per hour? Well, if we want to convert this rate, we just need to convert the units. If we want to convert to miles, there are 5,280 feet in 1 mile. So those units will cancel out. If we want to convert to hours, well, there are 60 seconds in 1 minute, 60 minutes in 1 hour. Our units of seconds will cancel, units of minutes cancels. And now we just multiply and then divide. 98,000 times 60 times 60 divided by 5,280, and that gives us 66,818 miles per hour, or per 1 hour. Please let me know if you have any further questions about this section.